90,000.
Testing 1 2, testing 1 2. 2 2 2 2. Testing 1 2, testing 1 2. Testing 1 2 testing 1 2 2 2 2 2 2 2. Okay, so I'll just get starting here now. We have some challenges again I want to address in this live stream, and it's regarding the frame. I want to finish the frame today if possible, so I can order all the stuff tomorrow and start prototyping. We have been discussing, we can have a look at the CAD model. So here is the current CAD model. This side thing, cabinet, pod, or what you want to call it, is probably going to be a little bit different. The touchscreen is not going to be here. If we are going with a touchscreen, we need to place it like down here or up top here somewhere. Let me know what you guys, where you would like to have it. Also take into consideration cabling, cable management to the screen. We want that to be as clean as possible and as simple as possible. So let me just get rid of the side cabinet for now, and also the enclosure. We're not working with that right now. So this is what we got. I currently have in the bottom here an 18mm MDF. Comes out at about 3.55 kilos, which adds weight to the base of the machine, which is good for stability and also lowers the center of gravity. I talked about this yesterday. If you didn't catch the live stream yesterday, you can do that on my channel. Also subscribe and like if you like the content. So my concerns right now about this frame is the joining. We have been talking about joining, and the community have been asked to apply blind joints. We're talking about blind joints. We're talking about just basically a panhead screw inside here. I can add a screw so we can see it. It's more easy to show you rather than to try to explain. So let me find a screw. Should be in probably I don't know, I don't remember where I put everything. So yeah, here we have a M5. So let's do M5 by 10. Let's put that inside here. Just need to do that actually in the frame. So let me activate my frame. And let's do like this. And I can show you. Let me also know, I don't know how the sound is now right now. So Mark, is the sound okay? Let me know in the comments. I did not do a sound test before I started, so yeah, I hope it's okay. So adding this guy to this guy here. Of course, it requires that the extrusions are tapped. and it would look like this. This is a typical blind joint with only just one panhead screw. We don't need a washer here. We could have a washer, but yeah, it's probably good without also. So it saves a lot of time doing this and a lot of hardware joining the frame like this. But there are challenges. Mark Bridgewater from New Zealand just did some tests, and it's not perpendicular. It's not the angle is not 90 degrees with this kind of joint. It requires a very, very precise cut, and some say milling as well, to get this correct. So this was my initial plan. It was asked for by the community, but if it doesn't make the best possible squared frame, we cannot use it. We can maybe mix and match. Maybe we can use these guys. Let me put one more in. So let's just see if we do put this one inside here. Yeah, I cannot access that right now, so let me just hide this one and put the screw in. Like that. This with two screws here in the 2040s, it should probably line up pretty good, but yeah, still we don't know. So let me put a bracket in. I'm not sure where my brackets are. Let me find a bracket. 2028. Okay, so I don't have those in this folder, this project. It should be somewhere else. Yeah, here we have 2028 L bracket. So I'll just copy this one out. Here we got it. It's all done as an assembly. So as you can see, there's a lot more hardware going on here. We have the bracket, we have the M5s, also washers, and the T-nut. So yeah, a lot more hardware, a lot more work, but I've used this before. This is my third or fourth 3D printer design, and I've been using these brackets earlier, and they have made a perfectly perpendicular or as good as it gets regarding the frame squareness. So we could put these guys inside. Maybe just need one. Or we could add two. I don't know. What do you guys think? This requires we put all the T-nuts inside before assembly, or we can suddenly not access to put the T-nuts inside, especially like down inside here. But Mark did the test with brackets like this, and the squareness was very good. It was like 90 degrees. So that's what we want. Also, another issue I want to address is that we need to have the Y rails. These guys, they need to be in plane with each other. It's not so important if they are skewed a little bit from the rest of the frame. They just have to be in plane. And then of course we adjust the bed, so the bed is in plane with these guys again, and then we will have a perfectly aligned system in the Y, in the X and the Z, which we need for a good result in our printing. So what I want to do here now is I want to move this bar to help align these guys. And I want maybe also to add another one. Let me just do that. And you can understand what I'm talking about. And also let me know in the comments what you guys think. Okay. So let me go to this rail. And I'm gonna make it a little bit longer. Currently, we have frame size X minus frame profile 2. Should I get rid of this one? Yeah, should have frame size X. Should do it for us, I think. Yes, I just need to adjust the joint. I'm actually gonna delete the joint. I'm gonna add a new joint. So let me do that right here. Like pick this corner. And let me see where we are now. Yeah, we want this corner to be over here. Yeah, okay. So I need to address this corner up here. And then flip it like this. 190 degrees. Minus 90. And then we need to lower this guy. And we want to lower it negative top lid top height like this. So now if I change now the lid top height, everything will align. If I go to the parameters and I change this to, let's say, 100, you can see what's going on. So everything just changed, as you can see. So if we go back, it goes higher, but everything stays where it should. So using this bar as like a plane, it will keep this and that extrusion in plane if we use this one as an alignment tool, but also it could be like a bracket. And then maybe we can use blind joints here for this one into that one, and also at least we can use blind joints here from this one to that one. Let me show you what I'm thinking. And then let me know in the comments what you think. Let's go to our hardware library and M5s. And just M5 by 10. 10 is probably maybe too long, but anyway, it's just to illustrate. So let me put this guy inside. And joining that one. can refer to, now I hit something I shouldn't, so we can refer to this thingy, and we can go 10 this way and then 10 this way. So yeah, and of course then we also would need, we can also go from the underside here and up into this guy. Different options here. That's probably better to go from the underside and up into this guy. So let's see how that could work. Yeah, -2 like that. As you can see now that the screw is a little bit too long, so it would need to be like M5 by 8 or something. And I can also put in, but of course this again is more work when we need to add the T-nuts. Let me add a T-nut. So these are open build T-nuts. There are different T-nuts available, of course. You can also use the hammer nuts. They are not as good, but if you are able to use T-nuts, then I would recommend that. And if not, then of course, and if you forgot some T-nuts, then use hammer nuts. So adding this. Here, over here. Oh, it just needs to be flipped. So, like that. So this is an option. And if you do that, you know, 2 screws here. We need to add holes here to access the screws, of course. And then this bar and that bar would be in plane with this one. And what we now could do is we could take this one and add even one more over here. But this is of course good for the frame. It's not so good for accessing inside the printer. Yeah, but of course the most important thing is to get everything in plane and rigid as possible. I don't think this will restrict our movement. We can have a look at that as well. Let me now put in the rest of the frame parts. Okay. So what happened here? Let me just see. Something weird happened here. Oh yes, of course. It's the it's the Z axis. Let me fix that. Okay, let's see axis. So trying to find, you know, there's a lot of components inside here. So you can see it didn't line up as it should. Okay, so I need to get rid of this joint, I think. And then let's join it one more time somewhere. Maybe we should join it to the lower bar. Yes, it did look like a cross gantry. Maybe we should build a cross gantry. What do you guys think? Should we stick with the CoreXY? At least this machine is gonna be CoreXY anyway. Like this. Yeah. So this is how it should be. Now it's correct. And then again, we could use blind joints from the top here and down into this extrusion. This one need to be tapped, of course. So again, I can show you what I'm talking about. Tapping this. And activating this one. So now we have a very good joint here, or maybe not so good. It depends if it's perpendicular or not. As to Mark's test, it would not be perpendicular. But I think this one will act like a bracket, so I don't think we need brackets here. Using this one, that one, and this one. And also, if we need, do we need this front brace here? I think we still have good access to the machine. We can put in the on the enclosure and see. I hope all the joints now are in order. Okay, something happened here. Yeah, I need to move this one a little bit down, or these guys a little bit up, but that's fine. Just a brief adjustment. So let's have a look at the enclosure. Yeah, I don't think this front brace is or bar. I don't think it's too annoying. What do you think, Mark? Should we add this thing to get the Y profiles in plane in a best possible way? Should we have this one only, or both, or do you have another solution for us? Of course, the step motors should be outside. I don't know how they ended up inside. Yes, it's because I turned this around. That's why, because they are joined to this one, so they should be outside. We can do that real quick. So we don't get confused. Just need to find it in the timeline. It's not always so easy. We have it over here. Yeah, the best is probably to just delete that one. Let's just add it once more. It's not so important at this point, but oh. Just bring it to the side a little bit. Something like this. And then the other AB motor. So these are called AB motors. That's because they work together in a CoreXY system. We don't have a X and Y motor. You can call them X and Y as well. That's fine. So as you can see, while I'm working, I'm using parameters as much as I can. Yeah, so they can stay there for this. I also just recognize that this one is too far to the side. It's not in the center. So I'm gonna fix that one. So it is this joint here. So it should only be frame profile divided by 2, like this. Come on. So Martin is asking why not use high temp motors on the inside. Yeah. That was not really an option for us. Do you have a link to some high temp motors? What's the price? What's the accessibility? What's the the temperature range and whatnot? I would like to have them on the outside. I don't see any point having them on the inside, but if you might change my mind. So something happened here now. I'm not sure what happened, but something is off. I need to fix that later. Sometimes when you do a lot of changes and you don't make the right joints, and when you delete some joints and add a new joint and it's not, maybe you twisted something, then stuff like this will happen. But it's an easy fix, but I'm not gonna use time on that right now. We are focusing on the main frame. So let me have a look in the comments. Maybe a temporary for the build and then remove. Yes. We could do that. But yeah, the rare one, we need one here anyway. We need one for this guy. Because, or we don't need one for that guy, because of course this one could stretch all the way up to the top. And then we could remove this one, but I feel like, how much weight is this? Let's have a look at the weight of this, because it of course adds weight to the top. If you have a look at the properties here, physical, it's 226 grams. So it means adding, if we add 2, then we add half a kilo to the top, which is not good. So maybe you have a good point there, Mark. Maybe we should just use one of these to align these ones. let me get rid of this one. Just the front one, yeah, but still we could now. Of course, we need this rear bar for our motors. So this one we need anyway. We need to be able to attach the motors somewhere on the backside here, and they need to be placed approximately where I have them right now, because I'm going to do a special belt run with some tensioners and stuff, so they cannot be on the side. We need to place on the side here for something else. So we need to place them around here somewhere, attached to this guy here. Yeah, so we could use just a temporary one for the front to align everything. I'm not sure we need it. I think that this one will align these guys, get them in a plane, and then adding in like the corner brackets. We should be good, I think. Let me bring back the front thingy, the front brace. So yeah, we could use this as a temporary thing for adding yeah. Maybe we should have, let me try one more thing now. If we do this one, let me make this a little bit shorter. Frame size X minus profile 2. So it removes 40mm. LDO. Yeah, for motors, I was thinking about, because I don't remember who did this test on motors, but E3D has some 0.9 degree steppers, which did perform very, very well. So that's, but I'm open for suggestions on motors, of course. So please leave us a note for suppliers and or the links for products. We need that. Let me now just find this one. Finding timeline. Not always they show up. Huh. Strange. Here it is, probably, yeah. It's over here. So let me bring this a little bit to the center now. So negative frame profile 1, like this. Because then we could have a bracket on one side here using 2040s. This is, I know Mark is building 3030s. But I wanted like the stock frame to be 2040s and 2020s, some 2020s. Of course, here we have a 2020, also up top here. And then these guys on the top here, we don't need them. Or do we? It depends on the top lid. I can come back to that just briefly very soon. Let me bring this one a little bit down. So let's find that one. So as you can see, it's not always they show up. Yeah, here we go. It's probably this guy. So we probably need to go down 20 or 40, I'm not sure. Let's find out. Let's find out. It's still off. Let me figure that out later. Let's add the enclosure and talk about the top rails. Let me hide this one. Also these guys. Because these are now not really needed, except for the lid. You know, we need the lid to close properly. We need to have something to close to. But should we just remove it? It saves some weight up top. It will help center of gravity. So if we remove these guys and add something else to the panel, which the lid can rest on and make everything tight. That could be an option as well. Always new stuff rises when I start doing something with the design, then another issue comes up. What do you think? Is this enough for our lid to close on? These panels, of course, could be thicker. They are currently only 4 millimeter, if I remember correctly. I have that in my parameter as well. Panel thickness 4 millimeter. So that could be maybe 6 or more. Depends on our supplier, of course, what they have and what not, what type of panel we are going to use. It should be some high-end stuff. Or not too expensive, of course, but they should look nice and they should have good thermal properties. But yeah, is this enough? Do we need the top rails? We can save 1 kilo now up top here, removing those rails. And it will be really, really good for the center of gravity. Still need the front top one if we use the other as a setup. Yes. Now we need this one, of course. I think I'll just order all of them. And then as we prototype, we can figure it out. I think that's the best idea right now. We cannot figure more things out in the CAD model. We need to figure it out by prototyping. So yeah, that was my thought for now on this. Moving this one to the top here. Now it's only got too short here, but it's gonna stretch all the way over here. Or maybe just to the middle and then use brackets on the side here. That's probably also a good option. Or maybe it's too much. We just have to start prototyping and then we'll see. So that was what I wanted to talk about today. Let me know now in the comments if you have any questions. So what do you guys think? Let me read the comments. So LDO motors has been mentioned. Are good up to 130 degrees Celsius. It says. A high temp is good up to 180, it says. Yeah, let's have a look at the LDO motors. But anyway, I would like them all outside. Maybe outside is too difficult, and then if we can go inside, then that's also a good option. With high temp ones. Printed brackets. No, Maker Viking. The printed brackets is not an option. We are looking at high temps inside this enclosure. So printed brackets will first of all not be rigid enough, and they will melt. It depends on the material, of course, but yeah, we want some metal stuff inside there. Regarding the printed X, C and Y carriers, they are printed at the moment. They are printed. We are looking to add an all metal option, but we need to find some suitable materials for these guys. I have some options there as well, or Mark has a spreadsheet with different properties on different materials. So it need to be accessible, and it need to be easily, not too expensive, and it needs to be easy to also print on a normal machine. So there are many factors coming into play, selecting materials. Yeah, but another just a comment. Yeah, it seems like we solved all the comments, and yeah, that's it for now. I just wanted to share this with you. So should we get rid of these guys? Should we add, brackets here? Or should we use blind joints? Or a mix and a match? Should we have the front brace here? It's not a brace, it's a profile. That's all what I'm thinking about right now, but I will finish the bill of materials for this frame now. Of course, having some extras, so we can figure out what's the best way, what's the best way to go for regarding assembly. And the price is not a big difference here. It's not the price that we concern, it's the assembly process and also the center of gravity. And that's it. Thank you for joining in. Let's do this. See you guys soon.